Okay.
Okay. Okay, so let's go for the Benguela case and all the steps within. So first we have to get the source code, as I said, and the useful data. So usually you can find the source code from WaveWatch or CROCO from Git repository and also for Oasis. You can go to the CROCO documentation. There is a tutorial explaining how to download the version. But for today, I've put everything already on the HPC cluster. And so to do so, you will only copy from my account the necessary files and source code. Just some note about that. I put some modification in the source code to help you today. So then if you have questions, I can show you a bit more because, for example, in the version of WaveWatch that we will be using, which is the stable release, there is one thing that is not compatible with the latest release of CROCO regarding the exchange of the wave direction. And so I've made some change in the WaveWatch files to be in agreement between CROCO and WaveWatch on this. And so you will find that in the repository that I will give you on Lecran today. So yeah, if you have questions, you can ask me a bit later. So first, let's start with logging into your Lecran account. So for me, I will just use an account that is nobody, I guess. Okay. And once you're in your home account, maybe I think Andres yesterday make you create a directory with your name or something like that. So I will do the same. And here you will copy first the source code that I have prepared for you from my instructor account. So it's a CP. From instructor 01. And so first you have to copy the CROCO directory there. You can see that in the CROCO directory, you have the CROCO tools and the CROCO code, source code. You also have to copy the WaveWatch 3 directory. So it's coming under WaveWatch 3. And here in WaveWatch, you can check that you have, so the version 6.07.1 actually, 9.1, but it's really the latest release from the NOAA you can find online. And then you have to copy Oasis, right? So these three directories you have to copy to your own home. And in Oasis, you can see that there are the Oasis MCT versions. So, and inside that, I have put a compile something. So compile Oasis 3 MCT Intel Lecran. It's a compilation that I've already performed for Oasis, where you will have all the libraries. And then you have to link some data because we won't do pre-processing of the different models today because it's a bit long. So I have already prepared these files for you, but it's basically the usual files that you can prepare with CROCO tools like CROCO Grid, CROCO Bulk from ERA5, CROCO Boundary Condition from Soda, and stuff like that. So basically, do not copy them because it's a bit heavy. I advise you to link them. So you can link the full data directory to your home. So now in your home, you should have CROCO, Oasis, WaveWatch 3, and a link towards the data directory. Into this data directory, you have the data sets that are useful for CROCO, And we have you have some CROCO files that will be linked to our own configuration and some WaveWatch3 files, basically. So in the CROCO files, you have the usual CROCO bulk, CROCO boundary, CROCO grid that have been performed the usual way with the CROCO tools. And in WaveWatch3 files, so you will have different input files for the grid. So the bottom bathymetry, the masks, the obstruction, the X and Y longitude and latitude data. And we have some also wind forcing from ERA file that is a bit in a different format for WaveWatch than from CROCO. And we have a former WaveWatch file that I run to start to perform the initial condition for the Oasis cover. So basically, you should have all this. And now we will also create a directory that is named configs, in which we will prepare all the configuration. So now you have the source code. The first step is done. Then we will set up the configuration and the environment in Lectaro. And to do so, you will go to the config directory. There, you will copy from the CROCO source, so data in CROCO2024 1.3.1, the create config.bash that probably you all know. I suggest that you copy that into your config directory, and we will edit this create config to create the Benguela configurations. So edit this. Here you have to set the machine. So the machine type here is Lectaro. This will help the script prepare the environment for you, so loading the good modules and stuff like that. Then you have to say where is the CROCO directory, so it's not there, so we have to change that. And we have to put from our home CROCO and CROCO-WW3. You also have to set the CROCO tools directory, which is not there either. So it's still in the home CROCO. So as it is written on the PDF should work if you have copied correctly the files. And the config name that we have, let's call it, for example, Benguela CPL. And then we will say where we are storing this configuration, and basically it's in home configs, and where we will work. Sometimes when you are on supercomputer, you don't have many space in your home, so you can put some heavy stuff and where you run the directory in a different directory. But today we will put everything in the home. But eventually you can say another directory where to work and to store the big files. But today it's the same. And here we will change also, you know, in CROCO you have several options to build the configuration. So you have the dev kind of architecture where it's for developers generally, where you don't have a lot of fancy architecture and just everything running in the CROCO sources. But I strongly advise you not to use that, because otherwise, if you're using it and you're starting putting stuff in your CROCO source and modifying stuff, it will be kind of a mess. So you should comment this line, and you should uncomment the option that is all prod CPL, which will help you build the architecture for the coupling. And once you have done that, you can save your file, okay, and you can execute the create config. And it says to you, okay, it's a reminder, your choices of the CROCO directory, you should check that it's okay, yes, it's in my student account. It's not good actually, because I put my name. I can see that, so I will say no. Do you want to proceed? No. because I forgot when I prepared the tutorial that you have your name somewhere. So I will edit back again the create config and check that actually my configuration is in home, but with my name. And here is my name again. And also for the source of CROCO, it's with my name and there in my notes. You have to check that also, because if you have put all the source code in your student donor with your name, then you have to propagate this here. So home, your name, and then CROCO tools, and configs. So I save this again. And now execute create config. Now I check CROCO directory is indeed in student 98 for me, under 20, CROCO, blah, 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 and configuration directory there. Okay, I say yes. Now, if I do an ls, I can see that I've created a Benguela CPL directory. And if I go into the Benguela CPL directory, I can see that now I have several things that way. So I have a backup of the way I create this configuration. And then I have several directories and several files. So there are my files, let's say, so my aunt, my path, my job, my name list. You will see that these are generally the my files that we will need to edit to work. Today we will only edit the my aunt, my path, because we will do everything by hand besides that. But tomorrow we will use my job and my name list. There is also a script that is named submit job that we will use tomorrow that goes with the my job and my name list. And that helps you submit jobs, indeed. And you can see that we have a various number of directories. So you have the usual CROCO files directory. You have the CROCO-in directory. So what is in this CROCO-in? Basically, in the CROCO-in, it's where you can find things that are related to CROCO, like the param.h, job conf, CPP dev, etc. So all what you need to set up CROCO. And you have the same for WaveWatch. So you have the WaveWatch 3 in, and in the WaveWatch 3 in, it's what is related to WaveWatch. So typically it's name list for WaveWatch, like the WW grid in, boons in, shell in, etc. And you also have the WaveWatch 3 files. For the moment, there is nothing in this directory, in the files directory, because we put nothing. But a bit later, we will put some stuff there. And you also have an Oasis in directory, where you can find typical NAM couples that you will use during the different tutorials. So you have these NAM couples are pre-prepared, let's say, to help you have the good variables to exchange, depending if you want to couple ocean waves, atmospheric waves, ocean waves, atmosphere, etc. And then you have a pre-pro directory that you can see. And in this pre-pro directory, you have various information for CROCO, WARF, eventually if you're using WARF or WaveWatch. But we will go into this a bit more tomorrow morning. For today, the idea is first we will edit the my on my path directory. And you can see in this my on my path that you have first several modules that are already written for you because you choose to use left arrow. And then you have all the good modules for left arrow. And you can check that you have some environment variables regarding NetCDF library or regarding the MPI launch that are already set up for you. And this was done thanks to create config machine equal left arrow. If you go a bit further down in this script, so you have still settings for compilers, and then you have some specific settings for different models that you can use. Here you have a reminder, so machine is left arrow, and then you have some paths, some environmental variables that will be used by the different scripts. So You check that your configuration is already Benguela CPL, as we have decided. Then you can see that the home of this configuration is in your home, and the work is also in your work. That's what it's automatically filled by the create config. Then you have the path to the toolbox, and here you have the path to the source code. So you have to check that it's the good path, and actually it's not for all of these. So for the coupler, it's in home, and then it's in Oasis, but no, I have to add my name because my home is home/12. Then it's into Oasis, and then it was also in Oasis 3 MCT, so you have to change that, huh? Be careful. And then it was compile Oasis 3 MCT Intel left run. So you have to check that, because if it's not properly set, it won't work then. So edit this export CPL variable with the good path. And then the ocean path should be good. So yes, it's in my home, student 98, Swen, Loco, What we won't use, so we don't care. And then we have to edit also the waywatch tree path, because it's not good either. So I have to put Swen, waywatch tree, and then it was waywatch tree, I guess, V6.07. And model, because in waywatch tree usually there are several directories and the model source and model. Then the toy we won't choose, XIOS we won't choose, so we don't care about these two passes. And finally, we have some paths for where to find the data. And so we can say that for today, this way is good, but for tomorrow, you will also have to set where to find the data for using bulk online. Probably, I guess you will use bulk online at some point. And so here, I advise you to edit that with C work. So it's coupling work, so a variable that is defined a bit earlier on proper files. So we will put everything there. When you have edited properly, so the CPL, export CPL there, and the export wave, which are the two most important for today, then you can save. And as it is environment variable, you have to source this file to have all the environmental variables properly set. This is important. If you log out of left arrow now and come back into left arrow again, you have to go there and to source this file. Otherwise, you won't have all the paths set up properly. And as an example, I will just show you that now I have this CPL variable that exists, and it is indeed pointing to somewhere. And if I do ls to there, I can see that, okay, yes, I have access to the Oasis library. And if I go to even lib, you can see we have this different Oasis library that will be called in the different codes. Okay? So to be sure, I advise you to check that you have something in your environmental variable that you will be able to use. So the $CPL and the $weight variable at least that you should have changed. Is it pointing towards somewhere where you have something? If it's not, you have an issue and you should go back to my path and set the path properly. Okay, now we have the environment. So we know the compilers, the libraries that we will use. We should compile. Oasis, as I said, I already compiled. So we checked, we have the libraries available. And I have a slide back in the end of the tutorial if someone wants to compile by itself, but for this morning, let's stick to what I've compiled. Then for waywatch tree, it's also compiled, so it is the $wave variable now. And you can see there that we have different compilation because we need eventually, if we want to use only waywatch, we have to compile with a given number of switches that you have seen yesterday. We have switched to different switches. But to compile in coupled mode, we have other switches. So if you check in the wave exit OW that I have pre-compiled, you have the different executable for WaveWatch running coupled mode, and you also have the switch file that has been used. And if you want to open this switch file, you can check that you have all these different switches that you have seen yesterday, and you have at the end switches for Oasis. So COO for coupling, Oasis for Oasis, and here a switch that is named OASOCM, terrible name, but it's for Oasis coupling with an ocean model. Okay, so this has been compiled with these switches, and now these executables are available to compile with Oasis and with an ocean model to run with that. Then we have to compile CROCO, because you know that WaveWatch and Oasis, we just compile them once, but CROCO we need to compile it specifically for our simulation. So to do that, I will go to CROCO-in. And into CROCO-in, I have the usual files that I'm used, like to compile CROCO, you need to edit CPP defs, so the CPP definitions, and you need to eventually edit the param.h, where you have the grid setting and the MPI settings. So first, let's edit the cppdefs.h. In the cppdefs, first you have to check that you want a regional configuration, so you have define regional. Then if define regional, you have define Benguela LR simulation, so it's a grid for the Benguela low resolution. You keep it that way. Then you have to define MPI, because as I said, Oasis needs MPI to communicate. So here you define MPI. Then you have also to define coupling. We want to coupling. So let's define ocean wave coupling. So define OW coupling. For the moment, you can see that there is a key undef OW coupling full. So keep it that way. It's what I said a bit earlier, that we can, with WaveWatch, decide to exchange only significant wave heights, mean period, and mean direction, or we can add other variables. But today, let's stick to only these three first variables. So, and then we have, for ocean wave coupling, to define also the key MRL-WCI, which is wave current interaction, because otherwise we just exchanging variables, but we are not adding any terms to the ocean current computation that are associated to waves. So we just communicate between the models, but we are doing nothing at the end. So you have to define this wave current interaction key. Okay, and that's all what we will define for coupling, but then we have to define also something about the surface forcing, because we need winds. And because of that, we will define the bulk. So you have to go down, 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 down in the surface forcing here. And you have to define bulk flux, because we will use the ERA 5 bulk flux file. So here we are good for CPP defs. So we can save this file. Then we have to edit the param.h. And in the param.h, first we will check the grid. So we have defined the configuration in CPP devs that is named Benguela LR, if you remember well, just before. So it's a bit long, but go down at some point now to the Benguela LR simulation. Okay. So it's indeed 41 by 42 points and 32 vertical levels, okay. And then there is the MPI settings that we need to check. So MPI related variables, as it is said there. And here you can see that if define MPI, you have to define the number of processors you will use in the X and Y direction. And I said earlier that we should run on 2 processors. So I will change this 4 into a 2 to when 1 processor in the X direction and 2 in the Y direction. So we will have a domain decomposition into 2 CPUs. Okay? And here we are good. So we can save param.h. And we are almost ready to compile. To compile with CROCO, we're using the job conf. So let's have a look at job conf. You can see in the job conf that we have a source to my/path. So this ensures that you have the good module loaded and the good compiler settings. You can check that the source directory is indeed pointing towards your CROCO sources. This should be set up automatically. Here you can see that for the compiler option is related to an environmental variable that we had set up with my/path. And there is something important here. We have a path towards the Oasis library, and it's under the $CPL variable that we have checked. Okay, $CPL variables indeed points to my compile Oasis library. So it was just for you to think that this root dir variable is important, but it's already set up, so you have nothing to do there. And now you should be able to compile, so you launch the job. And it should do something, yes. So you will see that compilation is slightly longer than when you're not compiling with Oasis, because we have a few additional routines that are compiled for the coupling and that are linked towards Oasis. And you can check that in one of this line, like MPI, blah, 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 if you look at it, you have all the compilation options that appear, and you can see that there are links towards the Oasis library appearing there. So if later you try to compile CROCO in a coupled mode in another computer and you have issues, check this compilation line and check that you have indeed linked towards the NetCDF and the Oasis library that are properly set up. This is quite important because it's there that you can check that it's pointing to actually where you want the model to read the libraries. So it should not be too long. And then if it's working well, you should have the CROCO executable appearing at some point. And I will just open another window to show you. So I'm just opening another window to show you that we are actually in CROCO.in. And in this CROCO.in, we have this compiled directories that appear, and it's where all the routines are compiled at the moment. So if you want to check also the Fortran code that is used by CROCO, you can have it in compile. But it's like you will compile all the time. So now compilation is over. And if I check, I indeed have now the CROCO executable that is available. Now I will move towards the preparation then of the configuration. So I go back once. So I'm in the Benguela CPL directory. There I will create a run test OW, let's say. It's where I will try my first run. So I enter this run test OW. So for the moment, there is nothing. And I will copy the CROCO executable that I need into this directory. So CP, I'm going to CROCO in, and I copy the CROCO executable there. And if you remember well what I said this morning, I need 6 characters for this executable name. So I will change the name to CROCO-X. Because wait, we need this CROCO-X. Just change of name. Then I will also copy the WaveWatch executable that I need. So I will copy the $wave, and here the executable, where I had, if you remember well, the CROCO executable, the WaveWatch executable, sorry. And I will copy all the WaveWatch3 executables here. And now if I look, I have the CROCO-X, and I have the different WaveWatch3 executable available. I also have to move the main WaveWatch shell executable towards WaveWatch for Oasis. So that's what I've done, WaveWatch. And now I have the CROCO-X, the WaveWatch, and the different other executables that are needed for WaveWatch to prepare the grid and the boundary condition eventually, and the wind forcing and the initial condition. That's Andres showed you yesterday. Okay. So now we have the executable. Okay, we can get the files that we need. So basically, I will go in CROCO files and WaveWatch3 files and link there the files that I need first, so that you can reuse them later if you want. So I go back to CROCO files, and here I will link the files that I had put in data, if you remember. So it's a home, Swen, and your name for you, data, CROCO files, and I will put all these CROCO files there. So here now you can see that you have all the CROCO files that I showed you a bit earlier over there. If I come back to my run directory, then I will link the file that I need for the simulation here. So what I need is the grid. So we first link the grid, okay, here. Then I also need initial condition. So I will need initial condition. So what I have available is SODA initial condition for the year 2005. And I need to link it as CROCO-in.nc. Okay, it's a general name that I will use. Then I will also link the boundary conditions. So the brief file from SODA also for the first month, and I will name it CROCO-brief.nc. And finally, I will link the bulk for the atmospheric forcing from era 5 for the first month under CROCO bulk. And now, if I check, I have indeed these files pointing to CROCO bulk, CROCO grid, and CROCO-in to the good file. Okay, so now I'm almost ready for CROCO. For WaveWatch, we will first link also in WaveWatch3 files the relevant files that we need. So we link what is in home, Swen, don't forget to put your names, data, WaveWatch3 files, and I will link everything that is ending by, or everything there first. So in WaveWatch3 files, so you can check that now I have these different available files for WaveWatch. There are some that we won't use, but it was just for testing. And now if I go back to to my run directory, so run tests, I will link the useful file. So first, I will link from WaveWatch3 files, the int, what I've called the int file. You will see that there are text files for bathymetry, obstructions, and stuff like that that should be prepared either by GridGen or by a little script that we have that can use CROCO-Grid to prepare that for you. For today, I've already done this step, so just copy this int file, and also you will need to link the era file, wind file for the year 2025 and the 12 months as win.nc. There, okay? So now in your directory, you should have this int file that appear there, and also the era file wind and the wind somewhere. I can, yeah, win.nc, okay? So now I'm almost done. So I have the initial condition for CROCO and the input files. And for WaveWatch, I have some ASCII files, but if you remember well, we need to pre-process that to a binary file that WaveWatch can read. So that's the step that we will do now. To do that, I've put this terrible schematic that is the WaveWatch3 workflow. It was a bit prettier, I think, in the manual, but it's missing some information. So, as Andres said yesterday, first we have to prepare the grid with the WW3 grid executable. So, from bathymetry, obstruction, and all this to have the mod.def file. We also have to prepare initial condition with the start to have the restart.wavewatch3. And we have to pre-process eventually boundaries. So today we won't use any boundaries. So all the waves that we will have in the domain will be locally generated by the wind. But then we need to prepare the wind forcing. Otherwise, we won't have any waves. If there are no boundary condition or no wind forcing, there are no waves. And so we have to use the PRNC executable to prepare the wind. So these are the steps that we will do now. So these 3 steps, grid, start, and PRNC. So to do so, we need the name list for these different executables. And these name lists are stored in the WaveWatch3 in directory. So we will first copy them. So let's go to the WaveWatch3 int, and let's go to take the grid int. You can see that this grid int is named .base, and you will see that because it's prepared to just change a few things inside. So let's link a copy here as WaveWatch3.int. Okay. Similarly, let's copy the PRNC, so preparing for wind, so PRNC.int.wind there as PRNC.int. And let's copy the start that we need also. And let's copy the shell that we will use a bit later. So it's named base also. And I will use ocean wave coupling. It's base.ocean wave coupling. But we have to name it shell.int. And finally, I will also copy for the output, because otherwise you will have the output in binary mode, not very easy to read. And I name it also WaveWatch3.int. So you have seen that I copy those with these typical names because the WaveWatch3 executable know that they want this kind of names to read the file. Okay, so the name list you don't provide the name of the name list. The grid knows that the name list will be WaveWatch3grid.int. If it's not this name, it won't work. Now let's edit this name list for the grid. So first, you have the grid name that you can put. So here we can put Benguela scale. Then you have the frequency settings. it's the default one, we will keep this. So you remember, this is the increment factor, this is the first frequency, this is the number of frequency, and then the number of direction, and eventually an offsetting direction. Then it's the activation of the model. So we activate everything except the first that is dry run, so it's activating nothing otherwise. One important thing is that the last true false flag there is for refraction. So for the wave model to compute refraction, and this is useful for current interaction. So if you want to have current interaction that we want, you have to activate this flag. If you are running a wave only simulation, not coupled, and you don't prescribe current, you can put that to false because it's not useful, and basically it takes a long time to compute. So I strongly suggest if you're wave only to put that to false. Then you have the time stepping settings that we have to change there. So you can see that everywhere here we have things into brackets, and this is because the script that we will use tomorrow are made to fill what's into brackets with other numbers automatically. Okay, so today we are just changing that by hand. So I will delete all these and change it with the time step that we have decided at the beginning. So the global time step is 3600 seconds. Then the CFL condition is a third of that. The refraction is half, and source time was 10 seconds. Then we have eventually a namelist section. Everything is commented for now because it will use only default settings for the parameterization, but eventually you can change that if you want for another computation. And then we have the grid settings. So here there are a lot of information on how to fill these grid settings. But typically we will use a curvilinear grid, and here we have to prescribe the size of the grid. So I have to change that. And as I said, it's the same than CROCO grid, so it will be 41 by 42 points. And then we have the names of where waypoints can find the longitude, and this is in file that I've copied a bit earlier. So the x.int, y.int. You will see that there are in my directory the bottom.int for the bathymetry, and the abstraction.int and the mask. Here we have also to prescribe the minimum depth allowed in the model, and I already put to 75 meters because it is very coarse CROCO-WW3 simulation of the Benguela region. Whatever in CROCO, we have a bathymetry that is minimal at 75 meters. So that's why I decided that. And here we are done. So we can save this file. And I just show you that indeed there, I have all these int files that will be used by the grid to build the model. Okay, in my directory. And now I have to run this grid. So I run the WW3 grid. I can forward it to grid out if I want, but I will just do that screen now. You can see that it's quite interesting. So it's writing the grid, and you can see the shape actually of the Benguela region appearing there. So it's 0 on the last, it's 1 in the ocean, and eventually you can have some 3 or some 2 at the boundaries that are places that the model either excludes the points from the computation or are supposed to take boundary conditions. Okay. And then in this output, you have some information about how many number of points I have, how many number of points of C I have, etc. So now I have the mod def file. So the grid for WW3 in binary mode is ready. Now I have to prepare the reinforcing. So I open the PRNC.inc file, which is the name list for PRNC. And here I have some settings to put. So I have to make this executable, understand what I'm going to look at. And you can see that there are the names of the spatial dimension of my reinforcing and the name of the variables. And I will go back a little bit because I you remember I linked the ERA5 file, and it was named win. So I will check what are the names in win.nc. And you can see in this win.nc file that the latitude is named latitude, the longitude, longitude, and the U and V win component are named U10 and V10. So I have to change that in winning in prnc.inf, otherwise it won't be able to read this file. So I go back to prnc, and here I will change the name because it's not LOLAT, but it's longitude and latitude. And the name of the variables are U10 and V10. And the name of my file is indeed win.nc. Okay. So I save that, and I have to run this executable. I won't run it with /, because if I do that, it will fail. I can show you, but it will fail because it was compiled with MPI compilers. Okay, so it's saying, I'm not happy. MPI is something I don't understand. Okay, it means that I have to run with MPI command, and in left root is MPI command srun. So we just launch that with srun. So it has to allocate me some resources, and it will do. Normally, it should. And this will prepare the wind for WaveWatch, so it will convert the wind that is in the netcdf file towards a binary file that WaveWatch can make, that will be named win.wavewatch3. It's not running yet. Maybe if anyone has run at the same time, it's creating some issues in the mastodon. Okay. I will do something else. So I will cancel this, so with Ctrl+C. And maybe if you can all cancel, I will just, we can prepare actually a job, because at the moment we are all trying to ask the node we are on it, in CROCO-3, to run something in parallel in MPI. So probably it's not very happy about that. So we can, instead of that, launch a job that allocates a node for each of us to launch these MPI settings. So to do so, we will have to prepare a job. Let's say job same way. And here we have to put some instruction. I will go a bit further down because I have them a bit later. And I don't know how to put them by heart. Okay. So basically, I will edit that with bash. I claim that I'm bash. Then I'm adding a line sbatch with job name pro, for instance. Then I'm adding a line saying that I should work on these partitions. And I'm adding a line also that's saying how many tasks I want. And I will say only one for the moment. And I'm adding an instruction that is saying that I want, like, let's say 5 minutes to prepare. Then I have to go where I am. So it's submit here. I will source my path to be sure to have the good environment. Okay, and then here I can relaunch my command. So it was RNC. Okay, this is fine for everyone. So there are instructions for the HPC supercomputer to launch the job on a node, on a dedicated node in API. Okay. So I have to submit that. I made a mistake. It's without an S, this partition. Okay. Okay, so now the job is submitted. I can check there. Spending.
Maybe you add the reservation.
Hmm?
If you add the line S batch, the reservation line.
Yeah,
On the scripts.
I can add it. S batch. We have a node reserved. No,
You got the CROCO-WW3 with lowercase.
Oh, okay.
24.
So 24. Yes, try that. First, I will check this. Oh, you can test the previous one then. I will launch it again. Still pending.
Wow.
Okay. Well, in the meantime, we can edit the following scripts because it's just pending. So basically, for the start, I can open the start.init file and so the name list to prepare initial condition for WaveWatch 3. And there, you remember yesterday, Andres said that you can start with scan condition, for example, this is number 5. But here I've decided to start with fetch limited John swap, it's 3, but you can put 5 if you want, whatever. You just start with flat water or wavy water built from the wind condition that we have at the initialization. Okay. And I will run that after also with the job, but not now because since it was pending, it's not running now. So.
It's running now.
Yeah, it is. It won't be long then. Should not. So basically, once we will have that, you see, there is win.wavewatch 3 that is appearing. So it's a binary file for WaveWatch 3. Checking if it's done. No, it's not done yet. If I open the output actually of the job, you will see that what is this preprocessor doing? So it's reading the mod dev. So I need to have the grid first set up. And so we check, okay, and it's reading the netcdf file also. And then it starts processing the data. So you can see that it's interpolating the data on the WaveWatch 3 grid actually. So for each date, so here we have a 1 hour frequency wind forcing, and so it's interpolating for each hour the wind forcing on the WaveWatch 3 grid.
And the input file is global. And
yes, the input file is global.
And you're extracting those the Benguela read.
Exactly, and putting it on the WaveWatch 3 grid that I have.
Okay.
So it's doing that. It should be done by.
May I ask something?
Yes,
If you have the wind, it's a smaller version now, where we can it put another source for wind to complete?
I think that in this preprocessor you cannot do that. Probably what you should do is first merging your two wind conditions that you have, and then provide that to the RNC, I guess.
I'm afraid model. Thinking if I have a atmospheric model.
Yes.
With the wind.
Yes,
Where
yes,
the atmospheric model is small.
yeah. So you have to merge the output of your atmospheric model with, for example, reanalysis conditions, but be careful doing that now because the wind can be, and then you provide this merge file, let's say, to the wave preprocessor.
Because it doesn't do. Doesn't match the atmospheric analysis data.
This executable doesn't do that. You have to do it before. Yeah. Okay, so this was done, and we can check at the end of the job that it went up to the end properly. So yeah, it's end of program, so that's fine. So now I will change the job to perform the start that I have prepared also. This will be super fast normally. So that's start. Let's go. Submit it. Okay. No, but it's probably just the time that it's allocated resources. So how many nodes do we have?
4.
Four. Yeah, but as it is MPI, it's booking full node, I guess, for each person.
Maybe we change the partition to the book. No one is.
Okay.
It's done, right?
That is very wrong. Very okay. Okay.
So it's done, and now you can see that I have a result.wave3 file. Okay. And I can also check that everything went well there, but basically, I'm sure it was. Okay, initial condition, writing, perfect. So now I have all my wave3 files ready. So I'm happy. I have my CROCO initial condition, my wave3 initial condition. And I can now prepare the name list. I can prepare the name list to run the following run actions. So I have to prepare the shell name list. So for wave3. And you remember yesterday, Andres showed you that you have in this shell.in file different flags to activate a lot of different forcings. And so you can put true to activate, for example, here the wind forcing. So yes, we want wind forcing. And for coupled mode, you have to put a C. So I want to couple with the ocean, so I want to couple currents and water levels. So I put a C for currents and water levels. For the rest, I put false everywhere. Then I have to put some information about the date I want to compute. So as you can see here again, we have brackets. So it's for the script that we will use tomorrow. But for today, I will just write them by hand. So I want to run from 2005, 1st of January. Seconds, okay. Up to, let's go to 31, January 31. Okay. So 30 days of running. Then I have to say to WaveWatch when I want, for example, outputs of variables. So here I also have to change the dates. So we put, I want basically output for the full run. So I start So 2005, 1st of January at 0 hour, 0 seconds. Let's say that I want output every 6 hours. And then I want to go up to the end of my simulation. So on the 31st of January. And here as a keyword names of the variables that will be output in the web watch. Okay. And then I can also prescribe different output, like point output is spectrum on given points. For today, I won't output that. So here I will just put, and I will just put, I will put date, but I can put anything actually, it will work. Because if you put 0 as a frequency here in the middle, it's just saying I don't want any output. One too much. Actually, I will copy this line because I will put it again a bit further. Because here is for a long track, so it's for generally for comparison with satellite data, for example. And here I will also change this line to 0. I don't want this kind of outputs. Here is for restart. So if I want to do a run for the next 30 days, I should decide to have a restart. So here, actually, I should decide that. So I will just decide to have a restart at the end of my simulation. I can, if I put 21600 like this, I will have restarts made every 6 hours. It's not useful for me. I just want to restart at the end of my simulation. So what I will do is computing the time in seconds for 30 days of simulation. And this time is that. So 2, 5, 2. That's 2 million of seconds. Boundary data I don't have. So I will just put 0 as a frequency for data, because I decided to not put data at the boundaries. And spectral wave fields, it's dummy for now, as you can see, so you can also put 0 there. And then finally, I have one section that is really interesting for me, is coupled field section. So there I have to say to WaveWatch another time what are the names of the variables that I want to couple. Okay. So and when I want to couple them. So here I also have to put the dates. So I will, and I want to couple, I need here to define, you remember I want to couple every 6 hours. But I want to do an average over the 6 hours of the wave variables. And the wave variables I computed every 1 hour. So I have to put there as a frequency the time step, the global time step of WaveWatch. For WaveWatch to be able to store these variables every 1 hour and set them to always that I can compute an average. So this is very important here to put as a frequency the global time step of WaveWatch. Okay? And then I have N is for name list, these keywords that says what type of field I'm exchanging. And so these are keywords that are WaveWatch specific. So I'm exchanging first the mean wave period, TO-1. I'm exchanging the significant wave height for ocean, so ocean wave height. And I'm exchanging the mean wave direction that in WaveWatch is named THN. I don't know, Tiffany programs. And I'm receiving from the ocean model the SSH, so sea level, and the currents. And here I'm done for WaveWatch. Then for CROCO, I also have a name list to fill. So for CROCO, I have to copy the CROCO.in that probably you know. From CROCO.in, which is base, CROCO.in. And here, if I open the CROCO.in, I also have to fill, so I have to choose a name, say it's Benguela CPL, for instance. It doesn't matter, actually, the name is just for what is written in your history of your CDS file. Then I have to prescribe the time steps also for the ocean and the number of time steps that we have to do to run. So to do 30 days of run every hour, actually it's 720 time steps. It's the way it's prescribed in CROCO. So we have a time step of 3,600 seconds, and the barotropic time step was 60 seconds, so we have to do 60 barotropic time step in one baroclinic time step, so 60 that. Then here I have to fill also for the vertical grid settings. So if you go back to my first slide where I've written this information, it was this. 72 and 200. Here start date and origin date, it's not used there because it's only for a given CPP that is named calendar and that we are not using right now. Then you can see that we have the grid file that is indeed CROCO grid, the boundary file that is indeed CROCO grid, and the bulk file that is CROCO bulk for forcing. And here we have also to prescribe the number when we want a restart in CROCO. So in CROCO, we want a restart at the end of the run, so after 720 time steps. And for example, this is for history and average, so these are the typical output of CROCO. So let's say that I want an output every 24 hours. Why not? Okay, you can change the setting if you want. So after this painful hour, I have set up my simulation for CROCO, for WaveWatch, okay, but not yet for OS.
And the CROCO.in, the start date, did you change it?
No, because it's only for calendar. I don't use calendar, so I don't need to change that.
CROCO doesn't really tell CROCO which variable to go to change.
In
CROCO,
what variable?
why would change?
I really, it's actually, we don't have to say if CROCO.in, it's OAD that will actually read the non-couple, and from what's written in the non-couple, we have a bunch of if in the CROCO code that say, okay, I read this variable, I need to change it or not. So we don't have to prescribe that. It's just from the directly read from the non-couple to OAD. Okay? So we can have a little break if you want, I think.
Let me stop the.
Yeah, and basically, actually,